So here is the review for your Chapter 5 test. So for A, B, C, and D, I want you to be telling me in your own words a little bit about what each of these is and what they do to the graph. So what I'm looking for is that you can sort of identify each one and then give me something about sort of what it does. So it doesn't have to be exact words. You just have to show me like that you know what it means. So the A value, so for each of these, the A is always that coefficient of your function. For sine and cosine, it represents our amplitude, which is the distance from the midline to the top or the bottom to the highest or lowest point. And for tangent, A represents the vertical stretch or shrink. So where those two side points on either side of the center of tangent, how far they go up or down from the midline. So then the B value, whether it's in factored form or not factored form, the B value always affects the period of the function. So we use B to identify the period. The period of sine and cosine is 2 pi over B, and the period of tangent is pi over B. So then C, and you always have to make sure that you factor out the B value before you identify C, is the phase shift or the horizontal shift. So either one is acceptable. For sine and cosine, with our 5 critical points, the phase shift is the first of our critical points. 2, 3, 4, 5. We add a period and we get the last. For tangent, that phase shift, so this would be sine or cosine, it would start at whatever our phase shift is. For tangent, the phase shift is the x value of our middle point. It's kind of our anchor point for tangent. And then D is our vertical shift or our midline. So the D value is always exactly how it looks. If it's +1, it goes up 1. If it's -2, it goes down 2. And that always affects the midpoint of like wherever the midpoint is. Like for tangent, it's like where the middle of the graph is going to hit. And then for sine and cosine, it's where the amplitude goes up or down from that midline. Okay, and then we're going into graphing. So I've given you graphs that already have labels on them for this one. So my expectation is that you can graph within the labels given. So I'm not going to be counting you on your labeling on this, but I will be counting you on the correct placement of points. So if we look at number 2, the amplitude is 5. Our B value is 1. So the period is 2 pi over 1, which is just 2 pi. And we do not have a phase shift, which means it'll start at 0, and our midline occurs at y equals -3. So I'm going to start by graphing my midline, which is at, at -3, so down here. And then I can sketch in my amplitudes because I know I'm going to go 5 up and 5 down from those midlines. So my high points will hit +2, and my low points will hit -8. And then from here, my start, because they had no phase shift, will be at 0. And since my one full period is 2 pi, my endpoint will be that phase shift plus the period. Divide it in half, and then divide it in half again. And this shows us where our 5 critical points will hit. So if I graph this, my midline is at -3. Sine starts in the middle. So we will go middle, high, middle, low, middle. So connect those, make sure that you identify correctly where the graph goes outside of those points, and then with your arrows. And that's what I'm looking for. Number 3, first of all, note the negative, because that's going to be important when we graph. But let's start with the amplitude, which is just going to be 1. The period is, our B value is 2. So B equals 2, 2 pi over 2. 1 full period would be pi. The phase shift, we can't identify that until we factor this 2 out. So we factor it out of x, and then we multiply our second term by the reciprocal of 2, which is 1/2. So this will be plus pi over 4. And I wrote the wrong bracket in parentheses, but whatever. Okay, so our phase shift will be left pi over 4. And then we had no vertical shift, so our midline is going to be at y equals 0. So we start with that midline at our amplitude, which is up 1 and down 1. And then our phase shift at negative pi over 4 means we're going to start here, and we add 1 pi to that pi over 4, which is going to be pi over 4 plus pi, get a common denominator. So our end point will be at 5 pi over 4, which is here. Divide it in half. Oops. Divide it in half. So if we divide it in half, negative pi over 4 is 3 pi over 4. This is halfway. That's why it's not working. It's negative pi over 4. So that's what's messing it all up. So this is not here. It should be at 3 pi over 4. Okay, so endpoint add pi, we get 3 pi over 4. So then we divide it in half, and then divide each of those in half. So here's our 5 critical points. All right, so we start at negative pi over 4. This is cosine, it is negative. So I'm going to start low instead of starting high. So start low, mid, high, mid, low. And then attach, indicate the arrows, and then we're done. Okay, on number 4, I'm going to have you change one thing. Well, there you go. You know I'm recording this at school. I'm going to have you change this pi to a 1 because we haven't talked a ton about doing a period without a pi. So I'm going to just keep it as 1/2. So to start, let's identify our amplitude, which is going to be 2. And then our midline, which is at 1. So I'm going to sketch those in first. We've got, midline at, 1. And then amplitude is 2. So going 2 up and 2 down from my midline. Then, to find the period and the phase shift, I'm going to factor out my 1/2 from both. So I factor out 1/2 from x, and then I multiply the second term by the coefficient of 1/2, not the coefficient, the reciprocal of 1/2, which is 2 over 1. So minus 2 pi. Meaning my period, first I'll do 2 pi over b, 2 pi over 1/2, copy, dot, flop. So my period is 4 pi. And then my phase shift is going to be 2 pi to the right. Okay, so this is going to be a little bit hard to graph because we can't get one full period on this graph. So what I'm actually going to do is I'm going to go backwards, and rather than shifting it to the left 2 pi, I'm going to shift it to the right, or to the right 2 pi, I'm going to shift it to the left 2 pi because it keeps repeating, so I can get in a full period if I shift it the other direction. So I'm going to start with my first critical point then at negative 2 pi. And then if I go out, add 1 full period, this would end at negative 2 pi plus 2 pi is going to end at, or plus 4 pi, right? 2 pi. If I start at that, shift to the left, and then I add 1 full period, I'm going to end at positive 2 pi. Then my midpoint would be here, and then my other 2 critical points would be at negative and positive pi. This is sine, it's positive, so it will start in the middle at my midpoint, and then it will go up, down, sorry, not down, middle, middle, down, middle. Okay, you could also have seen this if you had started at that positive 2 pi. You could go, you're up, and then your next one would be middle, because this is going at pi's. And you could kind of work backwards from sine. So like you could do your first start at 2 pi to 3 pi to 4 pi, and then you could go backwards to sort of see where this is headed. But I just like to shift it the other way so that I can do my normal sketches. Okay, number 3, tangent, everybody's favorite. All right, let's start by identifying amplitude, which in this case is a stretch or a shrink, and midline, negative 3. Then I need to factor out 1/2 from both terms. Multiply my second term by the reciprocal. 2 pi over 2 is just plus pi. Okay, period of tangent is pi over b. So we'll do pi over 1/2, copy dot flop, period, equals 2 pi. And my phase shift is negative pi. So for tangent, the first point we always graph is the phase shift, comma, the midline, because that gives us our middle point. So my first point is going to be at negative pi, -3, which is down here. And then I can find my asymptotes by adding half a period to each side of that. So half a period, 2 pi divided by 2 is just pi. So we're going to take our midline, or phase shift. We take that midpoint, the phase shift, and we're starting at negative pi. Then we add half a period, which is pi. That gives us our first asymptote at 0. So we can sketch that in. We can find our other asymptote by starting at that phase shift and subtracting half a period, which gives us negative 2 pi. So that's where we'll graph our second asymptote. And then we just look halfway in between each of those asymptotes in our center phase shift, and that's going to be where we're going to plot our stretch and our shrink. So from that midpoint, we would go up 3. So from -3 up 3 would land us right at the origin. And then from -3 down 3 would be at -6. So here. And we connect our points, indicate that our arrow is going to follow that asymptote. And then if we can sketch in one more asymptote, we know it's happening every 2 pi, and then sketch in one more, just a sketch. Again, it doesn't have to be exact, but it should be fairly similar, mirroring what we've drawn exactly, so that I can see that you know that there's more that happens on any side of tangent because it keeps repeating. Okay, part 3, writing functions from graphs and characteristics. So I'm going to give you an amplitude, a period, a phase shift, and a midline. I want you to write the function. So this one says a sine function, so we know we're going to use sine. So a is 2. The period is pi over 2. This is the part where we really have to do the math. So the period is pi over 2. I know that the period of, what in the heck, sine equals 2 pi over b. So I'm going to say 2 pi over b is equal to pi over 2, because I need to solve for b. I can't just put the period into the function. I have to figure out what the b value is. Then I'll multiply both sides by b to get rid of it. So then I have 2 pi is equal to b pi over 2. Multiply by the reciprocal. So I'm going to multiply by 2 over pi to get rid of it on this side. If I do it on one side, I do it on the other side. That gets rid of my pi, and I get 2 times 2. So b equals 4. So I'm going to put that here, because then I know my function follows this form, y, or in this case they're saying f of x, so we'll just do f of x. F of x equals a sine b x minus c plus d. And I just plug in what I know. So f of x equals a, we know our amplitude is 2, times b, which in this case we said was 4, times the sine of x. If the phase shift is right, pi, then inside of our, wait, I wrote this wrong. Ooh, I didn't write that wrong, that was fine. But I wrote this wrong. It should be like 2 times sine, because the b value goes inside our argument, 4, and then x, phase shift will go opposite direction, minus pi, and our brackets, and our midline is 3, so that's plus 3. If you want to, you can distribute this 4 in. You don't have to, but you just need to make sure that you identify it properly. If you do this, that is not right. So you have to make sure that if you're going to sort of put it in that final form, you must distribute the 4. So I would accept that. I would also accept this, 2 sine 4x minus 4 pi plus 3 if you distribute it. So either of those are okay. Okay, number 7. To write the equation from the graph, we have to do the same thing. So we have to identify A, B, C, and D. So the first thing I would do is, it says it wants a cosine equation. So I know that cosine starts high and ends high. So first of all, I can see if this is 1 and this is 2, which is sort of hard to see, so I'm going to tell you that that's what it is. I know my midline is at 0, and I have an amplitude of 2, so I know that A equals 2. I can also see that my period goes from negative pi to pi, so my period is 2 pi. Meaning, if I know that the period of cosine is 2 pi over b, and I can see that my period is 2 pi, I know that my b value is equal to 1. Then I can see that my function doesn't, where cosine usually starts at 0, it is now starting at negative pi. So my phase shift is, we would say negative pi in this case, because that's where we can see that it is starting. So we'd call it negative pi, and then my midline is at 0, my d value, because it has not shifted up or down. So from here, if I know that the parent function of sine is cosine b x minus c plus d, then I can just plug in everything I just found. For this graph in particular, it'd be 2 cosine b is 1 x plus my phase shift, because it'll be the opposite of what it's doing in the graph, and then not plus anything because there was no midline shift. So that would be the equation of this graph. Okay, last you're going to see one word problem, which will be something similar to this. Not exactly this, and obviously different numbers, but like you need to have an idea how to write an equation from a word problem. So this is a buoy in the Atlantic Ocean sends a signal to a Coast Guard station. The behavior of the buoy can be modeled by this function, so that's going to be important. Where y, the height, is measured in feet from 5 feet to 9 feet, with a 1.5-second interval between 1 foot 5-foot height and the next. So we know that this is like a wave situation. The highest height of the wave, it says, is 9 feet. The lowest height of the wave is 5 feet. And because of what we were given, we know that this midline is at 7, right? We know that that's shifted the graph up 7. So from there, we can identify our amplitude. So 9 is 5 above, or 2 above 7, 5 is 2 below 7. So our amplitude is 2. We also need to know the period, and they tell us that. So they say between one 5-foot wave, so like a low point, and the next 5-foot wave, that's 1.5 seconds, meaning that is one full period. But that's not our b value. We know that 1.5 would equal, because they said it's sine, so we know that the period of sine is 2 pi over b. We need to solve for b. So multiply both sides by b. So we get 1.5b equals 2 pi. I'm going to rewrite this as a fraction. 1.5 is 3 over 2, just so that I get a clean number. So 3b over 2. And then to get b by itself, which is what I want to solve for, I'm going to multiply by the reciprocal. So I'm going to do 2 over 3 times 2 over 3, because I multiply a reciprocal, gets b by itself. B equals 4 pi over 3. So I've got A, I've got B, and it tells us, it says there is no phase shift. We can see that in our original, and then we already have our D value. So I'm just going to plug everything in. Y equals 2 sine 4 pi over 3x plus 7.